thing, you can ask me. Hello, or am I audible to you, all guys?
Yes, sir.
Hello.
You are audible.
Okay. So any doubt
Yes, sir, you
related
are audible.
to Harish? So is there any doubt related to the layout things?
Sir, I have a
Hello,
basic
please.
question. Sir, we are not
Yeah.
performing any post-layout simulation. So how we will cater the parasitic effects, or how we will know that our layout is perfect, or our layout simulation is matching with schematic?
Got it. So currently, see, post layout simulation is will come later. Actually, the current scenario is the guys need to be familiar with the tool. Which is many guys are here who don't tool. Okay, so they also need to learn. So how I can directly jump to the post layout simulation for them. So first, they only need to learn those things actually, that how to do layout, how what is routing, what is the device, how the device layer looks like. Say many guys don't know even. So or many guys have very much good knowledge, so they might require very fast pace. So the guys who are here, they many of the things doesn't have the necessary details of the layout. So we will be going to post layout simulation after some time. Currently we are just making them familiar with the tool actually. Okay. Hello there.
Okay.
That only because if I directly jump to the post layer simulation, many other things many guys will get confused, because still many guys have a lot of doubts related to tool base, because they haven't yet get that tool only, that how to work on the tool. So like slow on. So step by step we will be going. Okay. Any doubt
Okay.
related to anything? You can. Okay, Uzair. Any
Hello.
doubt related to
Hello.
anything? Any topic? Yeah. Hello. Who's
Hello.
this?
Sir, I am Arshad, sir.
Okay.
Yeah. Yeah. Tell us. Tell.
Sir, can we do the with can we do this layout layer by layer, sir? Layer means
Like
layer
layer
by layer.
means.
In P means in PMOS, like we are taking generating from all from source, no, sir. Without doing generating from all source, we
Mm.
can do scratch from layer by layer
No,
the
you
devices.
want to draw each and every layer of the PMOS, right?
Yes, sir.
So the see that you can do. If you Rohit is in our batch. He is doing in that process only. In last class only, I had told Rohit. Rohit also had that same question in last class. So I've given in the answer. You can do it. Suppose for a particular circuit you have measurement of suppose 600 by 900, length by sorry, width by length is suppose 900 by 600. Okay, for that purpose you can draw manually. You have done. Okay, suppose in a circuit there are multiple width and length devices are there. Okay, so one device is 600 900 by 600 W by L. So one circuit has I can say 1.2 by 1.5 or any other parameter. On that case, how you will be doing, you should be have an answer for that one. So in that case you won't be able to do it manually, because doing manually for each and of the layer, you cannot make each and of the device every time, or every time you have to make the device individually manually for you. So how this is possible? For one or two device it's fine, but when multiple device will come, then how you will make it? You need something which should be immediately taking care of your device sizes as per your schematic. That actually skill language is. That cadence a skill language which is running in the background where you're generating a device. A skill language is automatically running at the back. So that skill language is taking care of the width and length actually here. That is the reason you are automatically setting the length and width as per your schematic in your layout. But manually when you will do it will not work actually. So that is the reason you can do. Of course, you can draw it manually. Let me show you. Let me show you once. It will be easy for you to understand. Okay. 1 second. Let me show it to you. 1 second. Let me show it to you. The problem, what will happen, I will let me show you. One second. Let the screen turn on. Okay. Suppose I have gone here. Okay. And let me. Okay.
For me,
Virtuoso and. Okay.
tool also creating problem, sir.
Yeah. I will check that one. Okay. In tools, let me go inside and library manager. Let me go to weekend. Okay. Suppose let me create one cell view name as test. I'm creating just a cell view. Okay. Simple cell view. I am generating it here. Okay. Suppose this is a schematic now. Okay. I'm create instance. I'm just taking one PMOS device. Let's say, I'm taking a PMOS device, or let's say a NMOS itself only I'm taking. Okay. It here. The size of the NMOS is width is 120, length is 100. Fine. I'm just connecting it like this. So don't go as per the connection actually. So it's just a random connection. Okay. I'm just taking this width 120. Remember this one. Okay. And let me go to the launch layout Excel automatic. Okay. Let me set this one 0.05, 0.05. Okay. Okay. Now, if I click on all from source here, so no pins are there. Setting the pins and press OK. A device has came for me here, right? Now what happened? Now this device has came for me here. Okay, so, Arshad and everyone, already a device for me. So is I'm audible to you guys?
So your screen is not
Hello.
updated.
Your screen is not visible, sir. We're not able to see it.
Your screen is not updated, sir.
Now is it okay?
No, sir.
Now is it fine?
No, sir. It's loading. Blank it is.
Now fine?
Just before it came, sir. It's not coming.
I think so. It's loading.
Let me change the internet actually. Is it now loaded? Hello.
No, sir.
No, sir.
Yeah, now it's loaded.
N-
Let me reshare. Let me reshare. Is it now coming properly? Hello.
Yes, sir.
Yes, sir.
Yes.
Yes, sir. Now it's coming.
Okay. Okay. Now let's say this is a kind of a device. Okay. Suppose you have been taking this device. Let's say, let me flatten one of the device and let me draw it for you. Because I also have to check the layers, what layers are available. Okay, let me see. Suppose you have drawn this layer manually. Okay, so to draw the layer, you can do one thing. You can just let me do one thing here. Let me separate them first. Okay, let me separate these guys. Let me first separate them.
Sir, some people will teach this devices by layer now, sir. That
Can
time
you
we will
repeat
get
again?
the ASIC. Some people will teach these devices by doing layer by layer, sir.
No, this layer by layer problem is there. I can tell this layer by layer. The problem will happen, I can tell you. See, when my question is now tell me, let me 1 second do. Let me 1 second. Let me do it for you. Okay. My first question is suppose in paint, let me go here and let me tell you one thing. Okay. Suppose if you have a schematic, okay, so you have a big size schematic, okay, here, suppose this is a inverter, okay, VDD, VSS output, okay. Now you have some other kind of circuit is there here, like this is suppose this is a current mirror, okay. Suppose this is a current mirror, okay, and it is coming from this is VDD, okay, and this is going to some other part in a differential pair now, suppose, okay, let's say, don't go this comment. Now tell me, suppose here this circuit has width, I'm writing here as W by L, okay, let me connect this one once, let me connect my pin, let me connect the pin once, and it should be easy to use. Okay, now suppose W by L here for this particular device of PMOS is 900 by 600. For this NMOS is 900 by 600. Now for this guy, this 2 PMOS, it is W by L is equals to 1.8 micron by 900 N. Okay. And for this one, W by L, it is equals to uh, 3 micrometer by 1.5 micrometer, suppose. Okay. Now, suppose Arshad, you have drawing this, the layer of this thing is 900 by 600. Let's say, let's draw it. Okay. Let's draw this guy. Okay. Now to do that one, what I will be doing here, first, what is the layer in this one? You can see what is the yellow in implant. Okay. What I will be doing, I will be taking this as a yellow N implant. Okay. Okay. So what is the size here? Let's say 120 by 100 only it is. Not going to that one. Let me take it to 120 by 100. It will be easy for me to draw it for you now. Otherwise, I will also get confused. Okay. 120, sorry, 120 N by 100 N. Okay. And this one is 120 N by 100 N, suppose. Okay. Suppose this is our design. We have been designing it. Okay, so 120 by 100. That's fine. Now I will be drawing a n implant. I'm going to this layer. I will then press R rectangle, not the path here. I will do rectangle means I will be drawing one layer like this, which should be of measurement of uh 120. Suppose let me measure this one only. Suppose I am taking this as a reference only. Okay, suppose it is 1.06 by 0.52. Suppose, okay, 1.06 by 0.52. Okay, let me do one thing now. One second. I'm changing this 1.06 by 0.52. Let's say, okay, let's say this is this guy. Okay, now let us measure it also. 1.06 by, so see, so I'm drawing it manually. Okay, was 0.52. Suppose, okay, same as this one.
Yes.
I have drawn it. Now comes the second layer, which is called our PW dummy. Okay, now I will be drawing this guy, PW dummy, where it is, PW dummy layer. Suppose, okay, what is its size? Suppose 0.48 by 1.02. Suppose, okay, and let me draw it here somewhere. I will fix the size. Okay, then I go here and let me type the width 1.02. 1.02 should be 0.48. Okay, and let me put it in the center of this one. Okay, so if it is like 1.06 and this guy is suppose 1.02, so what should be their centric point? Can anyone calculate and tell me? 1.06 divided by 2 and 1.02 divided by 2. Let me calculate and tell you. 1.06 divided by 2. 0.53 should be the center of the top one. 0.53. Yes, from here. Okay, from here should be the center actually. 0.53 the center for the top one. Okay, and for the below one, which is 1.02, to divide by 2, which is 0.51 actually. Okay, so 0.51, these both are matching at the center of, see, it is passing the center of this one. 0.53 center is passing with the 0.51 center of the below one. So means this red one is in center of the, is placed in the centric point of this yellow in implant. Okay, both things are matching. Okay, now come to this part. Let's say, now come to this part. So where this part was. Okay, now we will be drawing this part. Okay, which is 0.46 by 0.48. Now let me draw again this n implant guy again. So which is n implant guy again, this one. Starting from the top, it should be right. No, it should be inside this red guy. No, it should be inside this red guy, which the value should be 0.6 by 0.46, 0.46 nearby 0.48. That should be fine. Already 4.8 is there. That should be fine here. And then this should be also in the center actually. Okay. So let me put it in the center, which is 0.12, and this measurement is 0.46. Okay, so 0.46 divided by 2, which is 0.23. The center of this guy, so its center is 0.51. Okay, it should be matching 0.23. Okay, means the now let me put it inside this one. Okay, 0.23 exactly it should be. Okay, now let me move it and you can just check the measurement from both sides. It is coming exactly or not. 0.28 from this side and 0.28 should be from this in center. Okay, now up till here drawn. Now what I can do here is I can draw these layers also. Okay, I can draw this kind of layers also. So this small layer. So we can draw this layer, or I can you can see this layer actually. If you see this layer, you will able to see 0.24 by actually measurement is up till here only. Okay, let me do one thing, rather drawing it like this. Let me take a copy of this one and let me flatten it once again in P cell. Okay, and let me copy this itself only. That will be better. Okay, I'm just copying this guy, nothing else. I could have drawn it, but it will take a lot of time for you guys only. It will take a lot of time. So better I am drawing it like this only. Okay. Now I place it somewhere here. If I check the measurement of this guy from both the end now, you will able to see 0.18 from left side, 0.18 from right side, left side both. Okay. Here also it should be same. Point, no, not it is actually, it should be going 0.18 from this side. Okay, it should be up till this length, which is 0.18 up till here it should be, and it should be from this other 0.18. Now, okay, if you see this guy, we have drawn this one manually. Okay, so you can just note it and you can draw again and again these layers. Suppose this layer have been drawn. Okay, now you guys got how to draw the layers. Can you confirm me? Hello, 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 hello.
Yes, sir. Yes.
Yeah, Arshad, everyone got how to draw the layers?
Yes, sir.
Yeah, yes.
Okay, so now my question is, that's fine to draw the layer. Okay, means you are creating this as a P cell, parameterized cell. Okay, suppose you don't have these things available, just remove them. You have guys drawn this layer. Okay, for this particular circuit, you have drawn this N type material. Same you will draw in the P type material, so PMOS also. Now tell me how you will be drawing this layer. W by L, this one for this 1.8 by 900 when you have multiple huge big circuit. Now, can anyone tell me how to draw this one? This W by L when you have a multiple circuits to use. Now, let me show you one example of this one. Let me delete this PR boundary. Okay, and let me take this one up till this length, and let me put it take it somewhere here. Okay, I'm taking it somewhere at this level. I'm just making it at origin. Okay, let me put here at origin and move origin. Okay, okay, I have drawn this N type material layer. Now if I press save, I have to go my this suppose this layer has been drawn. Suppose this is a layer which has been drawn. Okay, now if I draw a different schematic, suppose inside I am going here and creating other name like a TST test 2. I have created one other file name in schematic. Okay, I will be drawing one. Again, I will take one NMOS 1 volt and I will pasting it here. And then what I will do here is I will be just drawing it up till here, then up till here, and then this should be up till here. Okay. Now I want to generate a layout of from this guy. Okay. I will be taking cell name up till here. So 1 second. 1 second. Let me. Okay. Now I want this, suppose this to be drawn, and I want this to be generating a layout for me. Suppose I am going to this layout Excel here. Okay. Suppose I have drawn this size is suppose 500 by, okay, 12.
So your voice is not audible.
Is it audible now?
Yes, sir.
Up till where you have able to hear me?
Up to that generate from sources.
Like generate from sources means like, okay,
Layout generate from.
okay. Now I have changed, suppose I have done the generate from source here. Suppose I have done generate from sources. I need this device in my layout. Okay. I need this device. But this device library is the not one what we have drawn. We have drawn that guy in weekend library under the cell name test we have made it. Okay. This is the layout. This is the schematic. Okay. Suppose now let me do one thing. Let me close this one. Let me close this guy. Okay. Let me say here. No, I don't want to do it. Okay. I let me go here and let me delete it. Because I am deleting this guy completely. Okay. And let me instantiation go here, browse here. Okay. Weekend test here. See, I don't have any kind of schematic available, which should be helping me to generate this kind of layouts. Okay. The problem you will be facing those things only here. Okay. So still also we can do one thing. We can go to the schematic and we can draw one, what I can say, we can draw one design. Suppose we are, let me draw one design for you guys. Let me draw one symbol things from here also. Okay, let me draw one. Okay, then it will be good for you to understand. Okay. Let me go to cell view. From cell view, let me create one guy. Okay. So left pin should be input. IN. Top right pin should be OUT. Top pin should be VDD. Bottom pin should be VSS. Suppose let me create one layout. Okay. Name it as a NMOS. I am also naming it as a NMOS here. Okay. Now, if I try it like this, let me delete this guy also. Okay. Now I want to draw this symbol here, suppose. Okay. Now to draw it, what I will do here is I will be taking this guy. I will be taking it up till here. Let me draw these guys. Okay. Let me draw these guys up till here. Then I will be drawing this up till here. Okay. And let me fix it first. MOS and MOS. Okay. Suppose this is a device we have drawn, suppose. Okay. And I'm deleting this guy from here. Okay. And this should be, let me not rename, this is like this. And let me stretch this guy up till this level, suppose. Okay. And how the schematic looks like this kind of. Okay. Like this kind of, it somehow looks like. Let me delete it. And then let me take it up till here, and then I let me put one device here. Suppose I am putting one device here. Now let me delete this also. Now suppose I have to put it like this also. Okay. I am putting it like this. One second, why it is not moving? Suppose I am putting this guy up till here. Okay. And let me align this both of them up. Okay. We should not align it. Let it be. Okay. Now I want an arrow to be here. I want an arrow to be here. I want an arrow to be here actually. Okay. I suppose put an arrow at this level somehow. Okay. Suppose I put an arrow like this. Just like this, I'm putting an arrow somewhere here. Okay. I'm putting a somewhere here an arrow and I'm saving it. Let me close it now. Okay. Now in the test 2, I have been here in this level. Okay. I will be just going to this part, this test 1, and this symbol is coming now. Okay. I am putting this symbol here. Okay. I am putting this symbol, suppose. See, now this how you do na? I am putting this symbol only. Okay. Now I am doing symbol check save. Let me do one thing. Let me connect these guys up till here to here, here to here, and then here to here. Okay. Now let me do one thing. Let me save it and let me go to launch Excel now. Okay. Can you able to hear me now? Hello.
Yes, sir.
Yeah. Okay. Then let me fix it now. 0.05. Then make it as 0.05 and set OK. And now let me go to generate all from source. It should be like this, and press OK. Now what happened is I am able to edit any parameter of this device. Can anyone tell me is I'm able to edit any parameter? Suppose I
No.
want to change this W and L. Can I edit them? Or
No,
can
sir.
I? We cannot edit them even. We are fixed in this one, but we need a device which should be of 1.8 by 900, suppose, of any other device. Our device length is fixed in this one only. This 120 by 100 only, it is fixed actually. If you see, if you see this one, it is fixed in this one only, this 120 by 100. We cannot change it to 1.8 by 900. If you want to do this one, we have to manually draw these layers of that measurement, then only it will come. When we have a huge size of circuit, we cannot do this kind of task. We have to generate it all from source, because in the background there will be, if you see, if you have looked around the, suppose let me take one example of let me take one device some around from here. Okay, let's suppose this only I'm putting it here. Okay, if you see some kind of, if you go this query this device, you will see CDF parameter is there. Okay, this CDF parameter is the parameter which is decided actually to that, which decides actually the device width, length, finger multiplier, many perspectives. Okay, it decides many perspectives of the devices, length, width, and many things actually it decides. So this thing, how you will be aligning it. So for making this thing, there is a complete different step. You have to make this thing individually. You have to first create the schematics, then you have to create the layout. Then those things you will be using in your uh, what I can say, in your devices. For each and individual devices, you have to create you cannot create any different layers. At last, if you also individually make this kind of symbol, then this CDF parameter, the skill language, align that skill language with this one. Then you create one layout of that device and align this one, and then you generate by making one. Suppose you have make one big XOR gate or full adder schematic. Now you want to use the device which you have made on your own. At last, you have to go in all from generate only. You won't be able to do it like every time making different size device. So that's not an actually objective. That's the, see the like you told, some guys are making it layer by layer. Layer by layer is done when the tool is not capable. When I learned, so there is a tool in internet, you will see LASI. LASIA tool is there, layout and schematic integration, some name is this one. So if you, in that one, it is not a schematic driven layout. In Cadence, the layouts are schematic driven. How the schematic is done, layout is the how it works. It is called schematic driven. When it is not schematic driven, then you have to make each and every layers individually, of each and of different sizes. On that time you can make. But when you already have a schematic driven layout, why you will go and make that layers every time? It is already it will become a huge task for you guys only. Now you got Arshad.
Yes, sir. Sir, my point is for we will come to know the DRCs now, sir, by doing layer by layer. That is my point.
You will come to know the DRCs.
Yes, sir.
So
Enclosures, contacts, like that.
okay.
Sir, he can also know this thing from the routing.
Who's that one?
Sir, this is me, Uzair. Sir, I am
Okay.
replying to his question that he also know this thing from doing the routing.
No, routing, see, routing is for M12, it is for the metal DRCs. When you are drawing metals, na, from M1 to the higher metal, routing takes care of that DRC part. Okay, so that base DRC you have might have heard what is base DRC. In that base DRC, this kind of things are contact DRC, N-well, P-well, implant. So this DRC for this one, the thing you can do here is you can suppose taking this device, you can draw anytime, you can draw these layers, you can check them, you can according to the what I can say, according to the device length and width, then you can easily draw the DRC. And for to DRC, to understand the DRC, you can read the DRM. It is much better way to understand the DRCs. You can read the DRM and you can create some test cases. Now let me do one thing for you. Let me show you one thing
Yes, sir.
that
Yes, sir. But if yes, sir. But if he can use via from M1 to M2, then there he can also know the contact DRC, because via is also made from the contact.
yes, he can. Of course he can. So that only I'm trying to
Yes.
say, you can for that one, rather making any devices, you can do one thing. Suppose if you take some test cases, suppose I am let me create one test cases for you, in which let me create level. Okay, let me okay one thing let me do level. Okay, let me make it that pass pass case. Okay, let me make it as a text layer. I want a text layer actually. Okay. text text layer. I want this guy. Okay. Let me do one thing. I am writing a pass here. Okay. It will not come like this. So better what I will do. Suppose I want to check a M1 to M1 DRC. Suppose example. Suppose left side, this side is pass case, this side is fail case. I will write it later. Draw one metal here. Okay. Draw one metal. Okay. Again, draw one metal here. Just copy it and paste it here. Okay. The distance between two M1 is suppose 0.12 micron, 0.12 micron. Okay. Let me do it. Okay. 0.12 micron minimum of the DRCs. Okay. To know this one, you can do one thing. You can create a random DRCs. Suppose you guys don't know what is the measurement. Just do one thing. You can create nearby. Don't create very far. Otherwise, DRC will only not come. Okay, it will not. It will not. It will pass the DRCs. So better put it like this. Simple. Simple. Put it like this. Okay. So suppose this is a case. Understand, this is a case actually. Okay, for metal 2 also, what I will do, I will copy this one, I will paste it below, and I will change both of them to metal 2. Okay, metal 2. Oh, where is the metal 2, man? Metal 2. Okay, now for the contact, what I will do, see, this is a contact guy, white one. I will be taking, suppose this guy here, I will copy this one below, and I will making this to contact cont. Okay, so I will make it to cont layer. Okay, and okay here. Suppose, see, if you zoom there, you will see a very thin spaces between them. Okay, now what I can do, I can save it. I can go to Ashura, run DRC, uh, and simulation. Let me run it here only. Rule file. What is our rule file actually? Okay, cadence. What is cadence here? 4.6 Ashura, and this is our rule. Where is that? drc.rule file. Okay, I have set this one, and let me press OK and run it. You can draw any layer side by side and check the DRCs. You can check the DRC anytime. This is a much more easy way to check the DRC, to understand the DRC things. If you now turn this on, see, you will be seeing This kind of tons of DRCs are there. How the DRCs are coming? Leave this P substrate or N substrate, that thing, leave it. You don't need it. Starting with the contact layer. Okay, I'm kind of contact layer here. This one I am highlighting here. This one. Who's that? I suppose I am highlighting. I see, to highlight it, go to that particular thing. See, currently these are turned off. When you click on this one, it will get turned on. Okay, I am clicking on this one. You can right click this one. You can make it at any color. Let me make it at green, and let me remove this with orange. Okay, I want to view this green color now. Okay, what I will do, I will go here simply, and I will, okay, I will be going here simply, and I will be making it. Okay, I will be coming at this level, and I will select NVEL, because NVEL is the easiest way to view the errors. If you come here and try to check these layers, we were checking this green guy, green one. What does it say? The contact shape must be 0.12 cross 0.12 rectangles. That is why the green is flagging around the whole boundary of the uh, contact. So it should be 0.12 by 0.12. Now, if you measure this guy, suppose if you now measure this contact guy, okay, the contact size should not be this much size. Okay, it should not be of this much size. Then what you can do here is you can come across. See, you are coming across. It asks 0.12 across 0.12 minimum. Contact shape must be 0.12 across 0.12. Go here, draw one. This is the fail cases. Now I'm doing the pass case. Do one thing. Go here. Okay, go in this one, select it and make it 0.12 cross 0.12. Okay, and press OK here. Okay, this should be our actually contact size. Now, if you copy this one and if you put it somewhere near to them, just I'm putting, I don't know the spacing between them. Okay, I don't know the spacing between them. Now, what I will do, I will save it and I will again go to Rasura and I will run the DRC. Let's check any other DRC except spacing comes there or not. Except spacing, any other DRC come in this guy or not. Okay, that 0.12 to 0.12, that error we have to find it out. Okay, let me, yes. Okay, okay, sorry, let me delete it. Suppose we have tested that this should be the size. Okay, now I am deleting this guy. Okay, I have deleted this guy from here. Okay, okay, now let me save it and again run the Ashura. Let's check that one, run DRC. Is it coming on this level or not? We're just fixing those things. Okay, yes, see that error. Can you anyone see that 0.12 to 0.12? It is not there. Means our that DRC particular, it is okay. We have drawn that DRC now correctly. So this is 0.12 to 0.12. Okay. Now the spacing error is the contact to contact spacing must be 0.14 for this guy. Okay. If I'm turning it this one yellow, let me go here and select it. See, you will be see that the spacing between them, it is flagging. So it should be, sorry, it should be 0.12, so it should be above 0.14 micrometer. Okay, so I will be doing one thing. I will be just measuring this area 0.14. It should be okay. It should be 0.14. Let me do it. Okay, let me take it up till here. Let me take this one up till here and align it up till this level. Okay, why it is not coming up? Okay, let me do one thing. Let me make it as 0.14 only. Let me do one thing. 0.14 micrometer, and let me take this and take this also, and let me make it. Okay, what's this value coming and why this is coming? Okay, sorry. It should be 0.14. Sorry, I was only making mistake. It should be 0.14. Okay. Now that this 0.14 has been fixed, contact must be covered by oxide or poly. So it should be covered by oxide or a poly layer. Okay. So I am not doing here. I am putting simple oxide here. Okay. Oxide layer. I'm drawing a simple oxide layer on top of this one. Okay, we will also might get some error on this one. Okay, now we will try to see this SP1 and X3. Mean it should be going. It should be going actually now. Okay, now let's run DRC here and do okay and okay. Now let's run it. Okay. Okay. If you see here, that two error gone. Now other two error has came. Oxide X1 oxide must be covered by N implant or P implant. Okay, that it is trying to say like that only. Okay, or N implant or P implant. Oxide E1 oxide to contact enclosure must be above 0.06 micrometer. Means it is saying that the distance between them should be 0.06 minimum. Okay, that these guys should be 0.06 from all side. It should be 0.06 from all side. Okay, this should be 0.06 from all sides. Okay, they should be 0.06 from all side. Like, let me take it. Okay, up till here we have done it. Now let me save it and run the Ashura. We have made it 0.06 from all sides. Now let me run it. If you see that all the error has gone for this oxide thing and the contact one, only this oxide X1 oxide must be covered with N implant or P implant or NZVT. Okay, so if you now draw the N implant on top of this guy, suppose if you draw N implant on top of this one, different question will be there. Again, you can go to run DRC Ashura and check whatever it is. You can go and check whatever it is actually. Okay, it will give some kinds of errors actually also now. Okay, again, an implant to oxide enclosure must be above 0.14. It says that this should be 0.14 micrometer from all sides. Okay, so actually if you see this one, let me draw it up till here, and 0.14, sorry, let me draw it up till here. Again, this should be up till 0.14 this side it should be up till this level. 0.14, this should be up till at this level again. Sorry, not coming. Why? 1 second, please. Why it is not coming? Okay, this should be also up till at 0.14 micrometer. Okay, it should, this is the enclosure actually. Now let's go to Ashura, run DRC and press OK and press OK here and yes. Okay. Now, if you come here, you will able to see the oxide enclosure. An implant to oxide enclosure must be greater than above 0.14 micrometer. So where this is coming again, error. 0.14 this side, 0.14 this side, point, okay, this side the error is there. Okay. 0.14 this side it should be also. Okay, now let's run it again. Now let me run it again. See, now if you see the contact you what you have drawn, it has given that all this kind of things should be going. Okay, all this kind of error should be going. So if you see the contact what we have drawn, the two white patches related to that kind of error, what are the requirement environment for those two things has checked and has been verified and the error have gone. So like this you can play with the tool. You can draw a couple of layers. If you now check the metal one, if you see the spacing should be 0.12 micrometer minimum. So you can just play with these metals also, metal layers also. This is the test cases you can create. You can create a couple of test cases to make your self familiar with the DRC deck. Okay, is it now clear you two guys how it has been done? Uzair, Muhammad, Arshad, hello.
Yes, sir.
Arshad, now
Yeah, yes, sir. I got.
no, if any question is there you can ask me. Might be confusing this is. And other guys, Harish, Pratusha, Sandhya, Saima.
So this in the layers tab, what is this AV, NV, ASNS?
Okay, AV is all visible, NV is no visible, AS is all selected, NS is no selected. Means suppose you have only selected this NVL, okay, and press NV. Except NVL, all layers will be turned off. So NVL is not present here. That's why it is not able. You can't able to see this one. Except NVL or the layer what suppose oxide I am taking and pressing NW. Okay, NV. If you go here, you will see only the oxide layer only. Other layer you won't be able to see anything. Okay. AS is all selected. This if you see V and S here, this is all visible, invisible. This is all selected, no selected. This thing only actually did not. If you press AV, everything, all the layer, whatever in the available in this black window will be visible. And NV only that particular layer which you have selected, apart from that other layers will be invisible. Only that particular layer which you are selecting, that only it will be visible.
Okay, sir.
Now got it?
Yeah, got it.
So you guys can play with the, suppose you have layer palettes this side. Okay, you have lot of tons of layers in the left side. You can use these layers by drawing over the editor window to play with. You can draw different layers. You can same layer. So the layer which you are putting in there, you have to put the same layer, and you can check the test case and fail case you can create. You can check those DRC things. So this the what I told you just now, this test case and fail case, this there is a job opportunity in this domain also. It is called QSL engineer. This is the part of the QSL engineer, the guy only responsible for checking each and every DRCs. In that one, some kind of thing checks are there: BDC check, block level density check, BOL check, this kinds of golden rule check, latch up check, this kind of terms are there. They only select those BDC checks. Suppose block level density check he or she will take, and inside the block level density, whatever the DRC is available, or the BEOL check, or the BEOL check, okay, in that one, if any DRC related to available, that one, this is because the DRC has been categorized within this. So suppose BEOL check, okay, that is called BCD, okay. Sorry, I think that block level density, that is called BCD checks. Okay, that BCD checks, Okay, 10 DRC from the DRC deck has been given. BDC, block level density check now. In that 20 DRCs are there. Golden rule check. In that one, suppose 15 DRCs are there. So when you tick mark on that one, it will check all those rules available inside that particular, or you can select individually that one also. So everything is available to do. So that is the called the QSL engineer job. That job vacancy is very less in the market. Very less company works on that one. Any company who has fabrication department, they only will work at that also very much less. Okay, so you can play with this layer. So this is the how you can play with the DRC rules actually in the layout window. Is it now clear to you?
Yes, sir.
Any guys having doubt related to thing? Sandhya, Pratusha, you guys? Saima, you guys? Hello.
Yes, sir.
Yes, sir.
Any doubt having for related to this?
And we need to practice it more, sir. Then we'll
Okay,
get to know that things.
okay. Saima, like you got the overview. I think you joined late. You got the overview.
Yes, sir. I'll start the layout soon. I still need to start the layout. Then I'll get to this point.
Okay.
Sir,
No, it's yeah.
Mhm.
Tell Arshad.
sir, can we do routing on the device, sir?
Huh?
Can we do the routing on the device?
No, see, routing on the device at the below layer is not advisable. That we will come when we will study the floor planning and routing thing. I will tell you that. But for a brief information, I can tell you when the suppose critical device when they are like differential pair, current mirror, when those kind of devices are there, routing over the devices at low level metals are not allowed. When you are going with the higher metals like metal 6, metal 7, on that time it is fine. But with metal 1 and metal 2, you should not be routing over the device like the critical blocks like differential play pair or the current mirror or any very critical biasing circuits. Like small circuit, it is fine, you can route over the device itself only, but try to not route over the device wherever it is possible. Wherever it is not possible,
Mm.
congestion issues there, you can route it sometime.
So I have a quick question, sir, regarding the layout. What devices we need to make on the layout? And as I see in the beginning of the classes, you have shown us the different, like the inverter, XNOR, NOR gates, and all that. So what we need to start the actual layout with? What devices we
No,
need to put in there?
see that in Norgate, see this PPT, right? You're talking about this PPT, right?
Yes.
Yeah, this PPT is just to make you guys familiar with the tool. See, many guys
Okay.
doesn't have the
Sure.
background of the tool itself only.
Mm-hmm.
Like they have never worked on the tool. Many guys have worked in advance with the tool, or they are working in the industry, or they have sometime exposure. But
Mm-hmm.
many guys doesn't have even the exposure to the tool. They were very new to this one. So
Mm-hmm.
they also, so they don't know what is this interface itself only. So those guys also need to know everything of the details. So
Sure.
then it will be difficult for those guys if I directly see. I can see if you see actual analog layout starts from floor planning. If
Mm-hmm.
you guys go, when you will guys go to the industry, the company when they gives you training, okay,
Mm-hmm.
in our weekday batch, some guys have been placed, okay, in some of the companies. The for they are 1.5 month in advance of this weekend batch. So some guys have been placed in the in companies. In that one, they are undergoing some trainings. The training hasn't
Mm-hmm.
started yet. They will be joining by next month first.
Mm-hmm.
So on that one, what happened, they will be going to training. In that training, they will not be trained like Linux basics, tool familiarization. The
Mm-hmm.
company is hiring them as a trained fresher, like a trained
Mm-hmm.
engineer or a trained fresher. They expect that guys we should know at least how to draw a inverter itself in a virtuoso. Okay, they expect that one only. Some couple of knowledge related to the fabrication they should have be they should know how to operate the tool. After that they will give guidance how to do floor planning, how to do partitioning, how to do base DRC, artist placement. Now what are the critical steps you need to follow for critical block like differential pair, band gap reference,
Right.
BJTs, like BJT matching is critical in the band gap. So that thing will be taken care at that level. So here many guys doesn't know anything. So I have to teach them for very basic, like from Linux basics
Sure.
only. I have to make them familiar with the tool. Then I have to tell them fabrication. Then I can go to the like floor planning also. Those are very advanced topics actually.
Sure. So, like in the library, as in one of the top in lectures, you mentioned in the beginning about make your own library, in the cadence. So, if
Yeah.
once you make your own library, so we can start adding the separate cells, like as you said,
Yes.
we'll be making LOD, right? So um, for that we are just you mean you're saying that we are just practicing right now to get the know-how of the tool, and then later
Yes,
on we can
library
start
is
the
just
actual project?
library is just to create your own. So you cannot create a library in cell inside this GPDK90 or the
That's right.
CDS TechLib. You have to create
Mm-hmm.
in your own on your own name. So I'm making a weekend. So in this only everything. Suppose we have two batches, weekday and weekend. Okay,
Mm-hmm.
so weekend all details will be inside this one. Weekday all details will be in that one. Okay, so I
Mm-hmm.
have to categorize them. If I
Mm-hmm.
go to the same library and put everything there weekend and weekday, then it will be confusing for me itself
Sure.
only. That is
Sure.
the reason I create a separate library to create separate library. In office also you have to make a separate library also. Okay,
Mm-hmm.
then you have to go to the cells. Then you have to see what are the designs you have made. You can create other libraries also as per the
Mm-hmm.
project. Suppose you are making a LDO project, you can
Mm-hmm.
make like LDO block there. In that
Mm-hmm.
one you can make different cells, and even you can copy those old library what you have worked now. You
Mm-hmm.
can use those cells also in your new designs. That can
Sure.
also be done.
Sure. So my another question is like the basic NMOS, PMOS, or basic inverters. So should we make? Do you suggest making those in our like a weekend library, and then bring them
See, you
out
can
for?
you can you can make it Sima's library or weekend library on any
Mm-hmm.
library. Anything you can
Yes.
make.
Mm-hmm.
That doesn't mean anything to that. Doesn't
Right.
have any concern with the layout.
Mm-hmm. So my actually I was just want to have a clear idea
Mhm.
on the layout that let's say if I make a schematic in the editor, in the
Mm.
schematic I make a schematic of the inverter. So can
Mm.
I convert that into a layout directly, or it's not a good idea?
You will make a schematic. Now you want to
Convert the
directly
schematic
control it.
into a layout.
So we are that is called schematic driven layout. Now what we are doing that only thing now here. Like you want that everything to be automated, right?
Yes, that's what I'm asking. Yeah. Mm-hmm.
That thing, if I tell you, let me show you one example, then it will be easy for you to understand. 1 second. Excuse me. Let me create one cell view inside this one, name as INV test with
Mm-hmm.
TST. Okay, I'm just making an inverter test on this one inside. Okay, and let me go here and browse. Okay, inverter is there or not? Okay,
I
let's
think last
suppose
time you
we are.
showed one inverter. I think it is, and maybe in that library and
I
90.
let it be. I'm
90.
just taking it this NAND gate itself only. Okay, I'm taking
Mm-hmm.
this NAND
Sure.
gate. Let it be NAND gate be here. Okay,
Mm-hmm.
I am taking it as a symbol, not taking it as a schematic. Okay, the schematic is
Mm-hmm.
inside this one. Okay, you got this
Mm-hmm.
one.
Mm-hmm.
Okay, now I save this one. You can. Okay, so okay, no connections are there. So let me do one connection here. Better it will be. Okay, let me do one thing. A connection should be there. Okay. Okay, one connection should be there. It should be A. It should be B.
So this one is like a simple, right? I was talking about the schematic.
Yeah, that
Like,
only I'm trying to say. That only I'm trying to say. The
oh,
schematic
okay,
is inside this block only. The
okay.
schematic is there. It is inside this block. I am not making the schematic again.
Mm-hmm.
If you double click this one now, you will
Then it
see in
will
a
show it. I see.
new see that schematic only. Again, I
Yes.
have to
Mm-hmm.
make it. I have to do the connection. That only I
Mm-hmm.
just copied
Yes.
that one.
Mm-hmm.
That's all only. Okay.
Mm-hmm.
And let me take the VSS here. Okay. Why? What is this one? 1 second. Okay, it should be VDD and it should be input output. Excuse me. It should be again. I have to then make the everything. I have to bring that. It will take a lot of time. So out. Let me make it as out and let me make it as output and let me make it as here. Okay. Suppose this is our design. Okay. Inside this one, the schematic is there. This schematic guy. Okay. When you are connecting this A B, it is connecting these ports automatically. Okay. So here it is coming here. Let me go to launch Excel layout Excel here. Let me uh, create new everything. I will create new. I will not do open existing. I will do automatic and sorry, create new. Let me do create new layout. Okay. 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 Let me go here. Let me make it 0.05 and 0.05. This should be and okay. Now let me go to all from source and let me make them to M1 pin. Sorry, in the M1 pin actually, when M1 pin here and update and create as level this one. Okay, and let me okay. That's fine now. Okay, now let me generate. Okay, if I generate them, you will able to see what is automatically coming here. It should not be there actually. Okay, it should not be there actually at this level. It is taking each and every layers. 1 second. Let me do it. I don't want this to be like this. Okay, that this should be better now to use. Now let me go to launch Excel, create new, and let's make it okay. 0.05 and 0.05. And this should be okay now. M1 pin update. Okay. Okay. Now our devices are here. Okay. Now what we can do here is we can take them automatically directly. You cannot do. You can do it. There should be an option called place actually here. Okay, so quick placement, place like automatic see quick placement. So place like schematic. If I put it here, it will be not okay. So better make it. You can go here like quick placement here should be then, or we can do here is automatic placement, maximal update PR boundary. Okay, it is placing the devices actually like this. If I now check the both devices, it should actually be here PMOS and the NMOSes are in the top. Okay. Now let me better flip them. I want to flip them. I don't want like this. I want to flip them, these guys. Okay. And let me highlight them and check. See, okay. Now what I can do here is, but the problem will be later will come. Okay. So better to do one thing, better align them with this respect. Take it here and take this one up till here. Okay. And okay, up till this level. 1 second. Okay. Let me go to Excel now. Okay. Now, suppose if I am going here, I am putting these devices somewhere here. Okay. I am putting these devices somewhere here. Okay. Now, what I can go ahead is route option is there. Automatic routing is there. Okay. You can go and click here. Okay. So there are multiple device labels. So you do not need to touch them. Okay. Actually, so you don't need to touch them actually. So just routing, we can just select the routing here. 1 second, it is not coming completely. It should actually come, but 1 second, let it come. Okay, and now it should be running. Let me click on run. It will do the routing for you like this. But can anyone tell me, or you can do here, like let me select them and let again run it. Okay. Can anyone tell me that is this routing okay? Like Saima, can you tell me is this routing okay? It is routing, but is the
No,
routing
sir.
okay? Yeah, hello, tell.
No. No, sir.
Is it optimized routing? The automatic, that
No.
is the problem of the cadence. The automatic
Mm-hmm.
routing is not good actually.
Mm-hmm.
You can do the automatic routing, but is this following any rules? It is just routing absurdly.
Mm-hmm. Right.
So see, the nearby point, if you go of the this one is this point. Okay, it should have routed this one, but it is routing it like this. So
Mm-hmm.
this is not actually a good routing. So that is the reason you have to do manually that thing.
Sure. Mm-hmm.
Now
And
clear?
also, sure. So basically, every single cell we need to build manually by hand, and then place and route just roughly, and then let the rest of the things can be done by the actual place and route and the top
No,
layer
no, no,
connections.
no, no, no. Uh, any connection you should not use that place and route thing. Only that in floor plan, if you go here, you will be seeing an option. I think a mod gen option I cannot see here. Like wait, you will see a option called create and edit mod gen. Except this one, you should not use anything, any option from this part. Mod gen is for only for matching patterns, common centroid
Mm-hmm.
interdigitization matching.
Mm-hmm.
Except, excuse me, except this one, you should not touch any of the thing. Even matching, you should be doing manually also. This is
Mm-hmm.
required
Okay.
when there is a huge size of matching. So in industry, if you go, guys don't try to, then they don't like to use mod gen also. They do if the big matching also by hand. Okay, the two save time, you can make mod gen. Okay, you can use mod gen, but you should avoid it. You should make it manually. So analog layout is completely like an art. You have to
Mm-hmm.
visualize it, and you
Sure.
have to make it as much as possible manually.
Sure.
Because when route, because this is IC 615. This is, I think, 10-year or 12-year old version. Okay. The current new version, if you go, which is IC 23.1, in that one still it uses generative AI. Okay. That tool even is not capable of routing properly or very good quality routing. That also cannot give that
Mm-hmm.
automatic routing properly. A bit of optimization is there, but that still cannot give that proper
Mm-hmm.
result. So that
So,
also you have to, only in that one some track patterns are there which helps to reduce the DRC, unless you have to do manually in every version of the layout
mm-hmm.
tool.
Sure.
Is it now clear?
Yes, sir. Thank you.
Okay. Any other guys having queries related to any topics? You can ask me.
Sir, you are switching between layout L and layout XL.
Who's this one? I can see.
Harish,
Oh yeah, tell.
you are switching between layout L and layout XL,
Uh-huh.
but which one to use, sir?
No, layout Excel only we have to use. The problem is, I tell you, the skill parameter of the device, if you see here, na, that this device actually creating issue. Actually, if you see here, if you see in this device, this middle one is available, na. In this one, you won't be able to see this middle one and not available. So that is the reason I switched back to, if I now pull this one and put it here, it will not work properly. Okay. Now, if I switch back to layout L normally, okay, it is only for this PDK only. Other PDK doesn't have that issue. If you now switch back to them and then you align with both guy, you will see that error will not be there. And then you can save it and you can again switch back to layout Excel. You will see that is okay. Now, every side it will be proper.
Again, in layout Excel, it won't be merged again. It will
No,
be
again
removed.
again it will be not much. If it merges, you can just go back and flip it. You can switch that one.
Again, we have to move then.
Yes, actually it is for this particular PDK only. In
Yeah.
45 nanometer PDK, I think it is some kind of bug inside that PDK, nothing else. It is some kind of bug actually, nothing else related to that one.
Again, if it merges, if suppose if it merges, then the distance between them changes and the routing also getting affected.
Yes, no. Routing will not get affected. What will happen? Suppose you have all thing routed. Now you see this had got merged automatically. Okay, see now you will be seeing there is a gap from this side. Up till here, this will a gap, a small gap will be there.
Yes.
That will be looks bad actually. So you can just flip that one. That's easy to do. It is a problem of this PDK only, nothing else.
Okay.
I will check if I have the latest PDK of the 9, because 90 nanometer is the old technology. Okay. So I have to check whether there is a 90 nanometer PDK updated version without this bug is available or not on cadence with cadence. I will check and if I get, I will send you all guys. Okay. You just need to put it in your device.
So
Yeah, tell.
body connection you are not taking out. So it's
Body connection. Okay.
yeah.
No.
Transistors.
Okay. You can do the body connection. So we are placing a tap in the top. You have seen that one, that big
Yeah.
tap. Or currently we are using tap, not a guard ring. Later we will use the guard ring also. The tap is taking care of that substrate. When we are connecting that tap, actually we are connecting the N-well to N-well also. You have seen.
Yes.
When we are connecting that one, it is actually taking care of that substrate body connection. Apart from that one, if you have a biased bulk there, suppose the bulk in the schematic is biased to some other ground or any other source of voltage, then what you can do, you can select the device, press query there, go to parameters here. Okay. You will be see option of body type. You can type detached. Okay. And left you want, or right or left I want. So I press okay. See, you will see this device available here. You can see it here. Or see, it is separated. This oxide layer is separated from here. If you want this to be query parameter, and if you want this to be body type integrated and left side with direction you want, you will be seeing it is connected properly. It is already automatically connected. If you do this one also, then you don't need that tap thing in the top.
Okay. So, but for NMOS, we are using for NMOS for a VSS also we are using tap thing, but we are not combining with the substrate.
So no. Actually, if you see the cross section of the CMOS circuit device, you will see that PMOS is isolated with a N-well.
Okay.
And NMOS is not isolated. When NMOS is directly connected to the P substrate. Okay.
Yeah.
But when there is a concept of a deep N-well, then one barrier layer will be there.
Okay.
That tap is different when it comes to the deep N-well actually. Okay.
That's true.
That concept will come later.
Okay.
like see, step by step we need to go, because as I told now, many guys don't have a idea of the layout tool itself only. Now if you now you can guys tell me, if I directly start with the advanced concept, what the situation for that guys will be.
Yeah. Okay.
As a starting only, I mentioned this batch is from basic to advanced, not advanced directly. So if it is advanced, then I would have started from directly floor planning itself only, not from the basic things. I wouldn't have taught that CMOS fabrication or tool introduction. That means I will be expecting the guys should be knowing the tools itself only. I will directly starting from the floor planning,
Okay.
because majority of them don't know. So I have to do it from the basic, very basic. Okay. Any other guys having queries? Asha, Duzair, Harish, Pratusha,
Sir,
Sandhya, Saima. Yeah, tell. Arshad.
sir, what is the importance of PR boundary, sir?
PR boundary is called place and route boundary. That is the, suppose you have purchased, after getting a job, you have purchased a plot, a land of 2000 square feet in a Bangalore, suppose in Kormangla, assume. Okay. In that one 2000 square feet, there should be a area that in this area only you have to make your house. You cannot go and make the house in your neighbors. You cannot take like 3 square feet from right side of neighbors, 3 square feet from the left side of the neighbor's house. You cannot take that one. That's a legal dispute. You have to go to the court and fight with the neighbor. So you have got a land area, that's border is there. That border is your limit. You cannot extend that thing up, left, right, top, bottom. You have to make whatever you do. You make house or you don't make house, you have to do inside that one only. You make a factory, you have to make inside that 2000 square feet only. You cannot go for 2000 0.5 square feet also. Is it now clear, Arshad?
Sir,
That is the perimeter. That is the perimeter you have learned in mensuration. That perimeter, that is the perimeter boundary. That boundary actually that is. You cannot extend, you cannot go apart from that one. That is only PR boundary. Any other questions for you other guys?
Sir, I have a small query. Basically, I am working as a physical designer, and right now I am working on the one of the tapeout in which there is some mixed signal block like BGR, LDO, and
Mm-hmm.
ADC,
Uh-huh.
and I am combining with them. Basically, the pad frame is a kind of mix. It have digital pads, IO pads, and also analog pads.
Okay.
I'm facing some trouble there. So I was wanted to let you know that when we will start actually the layout of the BGR, LDO, like this kind of stuffs. I can understand that these basic are also required for those people who are on the initial phase. But basically, I already know these kind of things. So if you have another class which is working in advance, or if you can just tell me the deadline that when we will start our jumps to this kind of advanced stuffs. Basically, I need it in
So
my
this,
tap out.
so
My
got it.
master degree is going late.
I got it. So this
Yeah.
kind of topic we are see, uh, this tool thing we will be ending by this week only. I will be drawing
Okay,
one
sir.
more example of this tool thing example, and I will be switching to CMOS fabrication immediately. Okay, and once the CMOS fabrication I should be expecting to complete the CMOS fabrication by first week of November. That like
Okay.
fabrication I have to tell every guys. Then I will be starting actual layout concepts in which I will be implementing, and I will helping the guys to implement the concept like EMIR, crosstalk, all sorts of thing. I will be helping
Yes.
you guys. In that one, you will be getting some ADC block. Suppose I will start with a suppose comparator. In ADC, comparator is used. Okay. In that
Yes, sir.
comparator, first we will be drawing that comparator block, how we will be implementing the thing. Then we'll go to the then using that comparator itself only, we will build the ADC block. Then after the ADC block is done, that ADC block we can use in our BGR or in our LDO block. And in LDO, that BGR we will use. So hierarchically wise, we will be working. Okay. So you have to wait at least up till November 15.
Okay, sir. Sir, and one more request, sir, that if we can lead one design to a full chip, like if we can take the ADCR comparator or one to two blocks combinedly, and then we can also design the IO FET and also the ESD circuit and combine the full chip. So it will be a good addition, sir, for this course. If we can design this kind of example too.
See, apart from the C, because every in the industry, I just frankly tell you, many guys wants to get into the job. Okay, so they want immediately that they finish the course, they will get placed in some companies. Okay, so in that one we had a time frame, we cannot like extend a year to, because creating a full chip will take time. Okay, we directly cannot make everything and make the guys. So what will happen, see, many guys are here from 2021 batch, and the industry looks
Okay,
very
sir.
fresh guys in the market, so they might lose opportunity in 2021 batch. They will say that no, we don't want these 2021 guys to in our batch no more, we have stopped hiring them. So we have to help them to get placed as early as possible. Apart from this, we are planning to launch our internship program, in which it is a paid program, in which you will be working on a live projects directly.
Okay, sir.
We are planning to launch the price is not finalized yet. We are working on that one. So in that internship program, that will be a 6 month rigorous internship program, in which you will be working directly on a live projects, actually, in which you will be working on a, because actually our company is moving towards product design also, in which we are trying to make in TSMC 65 nanometer. We are trying to build chip, actually, that IP in intellectual property we are trying to build. In that one, you guys will be adding as an intern, where you will be working in that part. You will guys will help us to build that part on that one. Okay. And
Okay.
once if you once the guy is actually, we see that guy is okay, he can go. Of course, that internship will be paid, that guys need to pay the fees for that internship part. And once we see that guy is capable of doing the such kind of layout, we will be trying to absorb that guy to our own company, and we will be sending aligning them to the work project directly with in the industry standard salary.
Okay, sir. So the remote opportunity is possible, or remote work is possible, because we are not from India, so we can join physically.
I understand that one, Uzair, but that things are completely global compliance. See, country to country, that terms and conditions are there. We need to check those things. We cannot assure you immediately, because see, those are cross border opportunity. These are okay, these are remote, actually cross border. Many
Yes.
guys from USA or Pakistan, from Sri Lanka, many things are different scenarios are there. We have to be inside the government compliance only for hiring any international candidates to make them remotely
Sure, sir.
work. Because see, many compliances are there. When we will come back to the internship thing, we will be, when we will be hiring the guy, not the interview, we will be hiring the guys for our own organization. We will be informing them as per the compliance. We will hiring them.
Okay, sir.
Once we hire them, you will get to know, because you are in the group, you are in the LinkedIn also, you are following Bharat IC, you will get to know everything.
Sure, sir.
If you're interested, you can show the interest in internship also. So you will be able to do the live project directly, in which tip in which we will do TSMC 65 nanometer or Skywater 130 nanometer. Whatever chip we are planning to make, we will able to make them. Actually, we can for our product part, like intellectual
Sure, sir.
property. Okay. Okay. Is there any other question for you guys?
Hello, sir.
Yeah, Arshad, tell.
Sir, here some basics you won't explain, sir. Like BJT about MOSFETs, like
I didn't got you. Can you repeat again?
you won't explain about the basic concept like BJT, MOSFETs, like sir.
Next module is
Yes.
that only, na? That fabrication and analog circuits
Semiconductor
only, na?
physics. Semiconductor physics. Like,
Yeah, yeah, that is the next part.
okay.
That will come in the next part actually. That will come in the next part.
Sir, regarding
In mo-
internship,
that
there will be 6 months internship, sir. 6 months internship.
yeah, 6 month internship.
For that, how you will
Six,
you
six,
will going
six
to hire,
month
sir?
to 6 month to 9 months. 6 month to 9 month, depending upon the project. Yeah, tell.
How will you hire for internship, sir? According
Like I didn't got how what is the hiring process will be, right?
yes, sir.
Yeah, see, we will be interviewing the guys before hiring them. Okay, and we will be putting advertisement and we will check the minimum the guys should be knowing the how to work on the layout, or the guys who are performing good in the this courses. We will be trying to offer them the internship actually to come and work with us. But apart from that one, so these will be paid internships. You guys need to pay fee for those internships. Those are not actually like that. Actually, those things are you will be working directly on a live projects of our own organization. That's all only.
We will not get any salary, sir, for that.
No, current internships you will not getting. So once you complete the internship, you will be if you guys like we find the guys good, we will be hire them and we will place them in some company directly from our company, or we will directly put you on a project. We will inform all these things. These are very debatable topics, so it cannot be explained in a single class. Hello.
Okay, okay, sir.
I will be telling this later. So currently we are not into this one. So I will be telling this one later. Okay. I will come across this one. First, we will be doing the placement things for you guys because I will be sending. Have I sent you guys those things that interview question things?
No, sir.
Okay, 1 second. Please give me 1 second. Give me 1 second. 1 second, please give me. I'm sending you that one. Guys, you can check in the group once. Weekend. Okay, you guys can check in the group. I have sent that interview questions, analog layout interview question, in which scenario-based questions are there and multiple different questions are there. You guys can start preparing. If you guide, answers are there. Majority answers are there. Majority some for some answers are not there. For that one, you can refer Chat GPT or you can ask me. I will be telling you the answers because those things I haven't tell because the answers, because if I tell the answers, so the guys will just mug up those things. You guys need to understand those answers, why this phenomena is happening. So that I will explain and you can write those answers in your copy or in your Word file, wherever you want. Okay. Hello.
Okay, sir.
Because we will be start making you guys to face the job opportunity by by the November itself only. Okay, so please start preparing with this. You start reading these PDFs, and immediately we will be now speeding up the classes. Actually, like a month has passed, you should guys now be expected to be familiar with the tool, practice as much as possible, because in the interview you will be asked what is CMOS things, like CMOS cross section, CMOS fabrication, how you can work on the tool, and what are the projects you have worked in the training, that these things will be worked on. So we will be completing up till those things so that you guys can face interview smoothly. So last tomorrow we will be only working on the module 1. From after the next week we will be speeding up and we will be start working on the fabrication part. In that one we will explaining BJT, MOSFETs, diodes, and all sorts of thing I will be explaining. In that one we will be working actually all over the fabrication with CMOS and FinFET fabrication will there. We will be targeting to complete those fabrication by first week of November. Okay, first week of November we'll try to complete, then we'll start the analog layout class so that you guys be familiar and you can work on the and you can face the interview and answer the questions. Okay, and any update related to the internship comes, I will tell you, don't worry.
Sir, another doubt, sir.
Yeah, tell.
Sir, our course is still running on, sir. At the same time, how you will conduct the interviews?
I didn't got your point, Arshad.
Means we are at the initial stage of our course, no, sir, right now.
Uh-huh.
You are saying that you will conduct the interviews at the November itself, sir.
See, November the process will start. In interview, many things are there. Okay, like the things will be like what I can say, CV building. That CV need to be finalized properly before sending to the HR partners. Then you will be like what I can say. You will be guided how to face the interview. Okay, like I will be taking our guys will be taking the some mock interviews for you. You guys have to face those interviews, which will help us to know that how much, or it will help us to you guys only to know how much you can be able to face the interview in the real time. Okay, then after that one on that time your CVs will be sent, and then you will be come across these things, and the HR partners will be contacting you directly or via us to help you to find the job properly. Okay,
Okay, sir.
but till that time majority of the concepts will be done, only projects will be left over, that you guys will be able to answer the questions in the interview, don't worry. Okay, you guys will be able to answer the questions. Only you guys need to do effort is, please try to use the tool as much as possible, get familiar as much as possible, use Google to learn more, and chat gpt will be very helpful. You can type any question related to the analog layout, you can learn from there. I am there, ping me anytime, I will be helping you, don't worry. Don't think that I will ping and I will not answer. Every time I try to answer the guys, whoever like ping me related to the any concepts. So please effort. See, like many guys think that they have paid for the course, they will come, that they will not learn anything, and they will get a jobs that good salary, because many guys have already put this kind of questions, sir, that can you assure me that I can get a 15 LPA job? So like how can I say that you will get a 15 LPA job or not, a 10 LPA job or not? It depends. Everything I can teach you. I cannot uh, confirm you that you will get a 15 LPA or 45 LPA or a 5 LPA. I cannot confirm you. Everything depends upon your labor, how much labor you are doing, how much practice you are doing, how much you are able to face the interview properly. Everything depends upon that one. And at last but not least, everything depends upon the market. If the market is stable, you can get a job with a normal college degree. If the market isn't stable, you cannot get a job even with a MIT USA degree also. Is I am correct, guys? Hello?
Yes, sir, that's true.
If the market is not good, then how guy will get a job? Even with the MIT degree also, he or she will not get a job. I have seen many guys over the LinkedIn. My one friend of there is there. He studied from California, Berkeley. He's still struggling to get a job. He is a PhD guy.
Sir, if you have a good skill, then there is lots of job in the silicon industry, as per
There are
my
tons.
knowledge.
There are tons of job.
Yes, sir.
There are tons. See,
Yes, sir.
currently India is growing in semiconductor field enormously.
Yes, sir.
They are going, if you go to LinkedIn and search for semiconductor job to analog layout and other domain of VLSI, you will find tons of job and tons of company in India. Yes, Saima, you are telling something?
Yes, sir. Even with a lot of experienced people are sitting, so it's not just the only degree. With the degree, people have hard time nowadays. It's like even with the experience, a lot of people are just sitting and
Yeah,
looking.
that only told
The
na.
market
Last
has
but
gone so
not
tough.
least, last but not least,
Mhm.
market is everything is market dependent.
Yes, sir. Mhm. So the interviewers, the companies have become very smart in lot of sense because nowadays since after COVID, a lot of people are, they are not as straight towards the work. Like you can say, like previously before COVID, the world was different. Now people want
Mm-hmm.
their own happiness first, and then they see people also leaving and coming back. So that's how it goes now. So it
Got it,
goes
got it,
both
got it.
ways. Mm-hmm.
Now, if I tell you the current situation of Intel is a big giant in the semiconductor industry. It is even in a such scenario that other small companies are coming and telling Intel that you want to sell your company to us or not. You can now understand the scenario now. So that has happened, that Qualcomm has approached Intel to buy their company stakes.
Yes, sir. And Intel have kick out lots of their employee nowadays.
15,000, recently 15,000 they have kicked out. 15,000, they have immediately 15,000 across the world they have kicked out. See, hiring, firing process is a part of a job. You have to accept that one.
Yes, sir.
Who can't accept, government jobs are there. You can try government job using arithmetic and study arithmetic and English and you can try.
Yes, sir. It's the part of life.
Hiring, firing is there. If you cannot hiring, firing, then government job is welcoming. You can
Yes,
go
sir.
and struggle there.
Yeah, with the
Yeah.
clearance and security and everything, sometimes the clearance part takes almost a year to come. So
Yes,
it's and other struggles are there as well on the
lot of
government
struggles are there.
jobs. Yes. Mhm.
Yeah, Arshad, you were telling something?
I forgot it, sir. What I'm asking.
You can remember, you can type in the WhatsApp, Arshad. Pratyusha,
Yes, sir.
Sandhya, Hari. Yeah, tell.
I got, sir.
Yeah, tell.
Sir, what is the difference between the analog layout and the physical design, sir?
Okay, the analog layout consists of analog and mixed signal both. And physical design is directly because for analog layout, you need a schematic actually. And for physical design, schematic is also required. But for physical design, using the Verilog code, you can synthesize them and you can directly implement them as per the standard cell. It is completely digital. Nothing analog is there in physical design. Okay.
Physical design is a huge domain, no, sir, compared to analog.
Both are huge because in a chip, if you see, both parts are required.
In
Like if
physical
you see
design,
the
in
Airtel,
physical design, there is a floor planning, power planning, placement, CTS, and routing like that, sir. In
everything
analog,
it is also there. Floor planning, placement, partitioning, power planning, everything is in analog layout. But
because
analog
I have
layout
completed,
actually, yeah, tell.
I have done physical designing, sir. I have completed physical design training previously. So,
Okay.
I have some
No,
knowledge of.
in analog layout also these things are available. I will come across those things. Okay. So in other power planning is how to do the power planning. These things will be also there in the analog layout part also. So don't worry. Actually, analog layout part deals with the higher voltages, and physical design is fixed to our digital voltage only. Like digital voltage, what I can say, suppose a 1.8 volt is the maximum of that transistor. Okay, so that the digital voltage, whatever is 0 1 1 logic, it will work. But in analog layout, you have to go with a higher voltage. Currents will be higher. That it is much more related to current constraint. RF domain will be there. So, like if you see, to run a PCB or at any chip, you need a power device. If you see the power device, okay, that power device is an analog layout because it deals with power management devices and like logic converters, ADC or DSC, then oscillators, then capacitors, resistors. These things are not available in physical design. Physical design is only comprised of NAND, all the seven in like what can you say, logic gates: NAND, NOR, NOT, AND, OR, XOR, XNOR, transmission gates. These 7 or 8 logic gates. This what I can say, this physical design is comprised of. In that one, you will not find any band gap reference design or any PLL design. These things are not available in that one, actually. Okay. You will not find any capacitor or resistor in that one. You will not find any diode in that one. Those things are not available in that one.
But there are very less jobs in physical design, sir. They are asking for now. They are asking 2021 pass, sir, currently.
No,
For
physical
physical
design
design.
has, see, physical design has also a lot of job. Analog layout has also a lot of job. Comparing both the domain is not good, and you cannot say that this has job, this doesn't have a job. Everything has a job. The guy need to be skillful. Problem here is actually guys are not only skillful. Then what the company has also some problem. I understand the market has also some problem, but skill is also a big matter actually. Guys cannot compete even the interview properly. They don't know even what is the saturation graph or the CMOS graph, either that MOSFET graph even. Then who will hire them? You tell me. You tell me that what is cutoff region, what is linear region, what is saturation region, and what are the operating conditions of a MOSFET. If that guy don't know and he or she is expecting a salary of 10 LPA or 15 LPA, as a CEO of a company, will you give the job to that kind of guy? Hello?
No, not at all, sir.
Suppose you are keeping a maid in your home who will be responsible for cooking and cleaning your home, but she don't know how to clean or cook for your home. Will you keep that kind of maid in your home? Will you spend your money?
No, no, sir.
So same concept na here. Problem is actually the guys don't have the skill itself only. They don't have very bad skill they have. So that is the problem actually. So no worries. So everyone need to learn actually. So everyone will get a chance to learn. We have to give chance to everyone to learn. So okay, not an issue. So okay, we can end the session here. It's almost time. We will be continuing the class tomorrow, and we will try to end the class this topic by tomorrow. Already XOR gate I have done for you guys using the NAND gate. One I will do is the full adder. Either the full adder I will be doing, or I think I can do a 2:1 mux and a full adder for you guys by tomorrow. 1 hour I will take for the 2:1 mux, and 1 hour I will take for full adder. Okay. Two things I will be completing, or we'll see. Either a big thing we will do or a two things I will be trying to complete it by tomorrow. And we will end this module 1 and we will try to go to module 2 by the next weeks. Okay. So that we can speed up our things. Okay. Okay, then we can end the session. Like I will be telling one thing. If any point or doubt is there, in a week I will be try to keep one extra session now onwards. If very requirement is there, extra session 1 or 2 session I will 1 hour each I will be try to keep in that one over the weekday, in which you can put your queries and doubts or any topic outside from the analog layout or advanced topic you can ask me there. But in the class, if you ask, it very difficult for us to complete the syllabus at a time, because everyone is waiting to get complete the course and to get placed actually. Okay, so you can ask in the class also, actually not a problem. We can discuss those points in the extra sessions which I will be keeping in a week, every week 1 hour. Okay, if required, then extra 1 hour I will do. If not required, only 1 hour I will keep in any weekday. I will be putting that 1 hour extra. Okay. Or over the weekend only 1 hour extra. That will be 3 hours on particular day. Okay. So it will be easy for us
Sir,
to. Yes, still Saima.
yes, actually, I have a quick question. So, all your lectures are being recorded and then they will be on the drive, right, sir?
Yes, yes, yes,
Okay,
yes.
okay, then sounds good. Mhm.
Everything is in the drive only. Na? You can go and search in the drive. You will find the lectures by